Okay, we're looking at the homework, or not the homework, but the actual classwork that was done in class yesterday, which would have been Thursday, or I'm sorry, Tuesday. Now, this first guy, we were trying to name what kind of a compound they are and what do we call the functional group. So, this dude is a hydroxyl. It's not considered hydroxide. If you have hydroxide with sodium hydroxide, yeah, in the molecule sodium hydroxide, there we go. Hydroxide with a sodium will form a very strong base, which you're aware of, I hope, or remember, I hope. So this hydroxide is not a hydroxide, it's called hydroxyl, similar name, but different, and the reason that it's different is because it doesn't act the same. When you put hydroxyl group on a carbon chain, it does not form a basic solution. In fact, it would be fun to test one. I'll do that later. But at any rate, this guy is considered an alcohol. And this is someone's paper from this period. So got quite a few of them wrong. So you want to take special note to understand exactly what these are, because in this exercise we've defined all of the functional groups that you're going to be responsible for. So this is a very, very good way to get them into your head. Now in this second one, we have what's called a carbonyl group. Okay, that carbonyl group indicates either a ketone or an aldehyde. Okay, this particular guy is a ketone. And the reason he's a ketone is because the carbonyl group is between two carbons. See, this is the carbonyl group, which includes a carbon. And he's between two carbons, which makes him a ketone. And this is another way that you could have written this particular molecule, which makes it look a little easier to recognize, doesn't it? Isn't that much easier to recognize? Okay, so this is exactly the same molecule. There's no difference. But the carbonyl group stands out really nicely here. I'm going to circle him in red. Okay, so there's your carbonyl group. So ketone. Now, does anybody know how it becomes an aldehyde? Where does this have to be for it to be an aldehyde? Anyone? Alan, what are you doing? Huh? Why? You need every point you can get, man. Okay, so here's the dude in the middle. How do we make an aldehyde? This is a ketone. Ketones and aldehydes are very similar in the fact that they both have carbonyl groups. But what makes the difference between a ketone and an aldehyde? Anyone? Okay, the first one to tell me is going to get a aha, good. An aldehyde has this carbonyl group on the end carbon, in which case he's going to look one of two ways. When the carbonyl group, well, here, let's wait till we get to a aldehyde, and we'll talk about it in more detail then. But right now, let's look at the amines. Okay, the functional group is an amino group. Have you ever heard of amino acids? Okay, part of your DNA. Okay, the sequence of amino acids in your DNA determines everything about you. It determines whether you're tall or short, blue or brown eyes, or any other color. It determines whether you're going to have perfect 20/20 vision most of your life, or whether you're stuck with eyes like mine that are causing you to have to wear glasses. And mine happens to be because of an astigmatism, which means the surface of the eye is not perfectly rounded. Okay? It has imperfections in it. And the lenses are able to change light to make that work. So I can see better with my glasses than without. Alright, so there's our amino group. And now if you look on page 738, you'll see an amino group there. But he looks different. Can anybody tell me what the difference is between the way it looks there and the way it looks on this problem? And come up and check the credit stamp. Whoever can tell me is going to get an extra credit stamp. What's it? How does it look different? Looks different, but it's not. And I need to know why. Now, in the chart, it's what? In this chart, the N comes first, doesn't it? But you have to look at this in a whole different way, like we've looked at all our organic molecules. When I turn this thing around, it isn't any different. And I'm holding up a ball and stick model now of hexane. And on the hexane, if I look at carbon number 2 right here, he's hooked to carbon number 1, and then he's hooked to 3 hydrogens. Okay? In that order. So whether he's on this side or on this side, and all I'm doing is turning this hexane ball and stick model, that thing is still going to have the same orientation to carbon number 2. Okay? And when you look at it right now, you could see it so that if you go from right to left, you see hydrogens first, then you see a carbon, then you see another carbon, and then you see 2 hydrogens hooked up to it. And because of that orientation, sometimes it snookers you, and you don't really see it quite properly. And so, and let's just take a quick look here on the Elmo, and I can show the same thing here. So what I was talking about is I have this carbon number 1, this carbon number 2. So if I go from left to right, I see hydrogens first, and then I see the carbon. And now I see the next carbon first before I see the 2 hydrogens that are hooked up to it. Now, if I turn this guy around, yeah, this is much better, isn't it? It's much easier for you to see what I'm talking about. And the people at home, of course, can see it, and they couldn't see it on the first time. But at any rate, now the hydrogens are on the right, and the carbon is on the left, as opposed to this way. So it's another one of those deals like I was showing you from the very beginning. The first time I gave you a carbon chain, I had that thing turning every which way, didn't I? And the reason was because you need to be able to see things in 3D space. So this is our amine group. It's an amine and the amino group, and that's an NH2, whether it's on the left side or on the right or in the middle, matters not. When we hook this guy up anywhere in the middle, which we might do, you want to hook up the N. The hookup point needs to be from the N and not from the hydrogen. Okay? So that's your amines. Now, here's your carbonyl as an aldehyde, improperly identified as a ketone. So I hope whoever paper this is here today so that you can fix it up. If not, you can see it on video at home. But at any rate, this is an aldehyde, and you can see how it looks. The aldehyde, whoops, went away. Now it's back. So let's look at this aldehyde in 2 different ways. I'm going to put dash, carbon, double bond O up here, hydrogen down here, right? There's a hydrogen down there. That's the way you see it in my tutorial. Have you all got my tutorial up? The organic chemistry tutorial? If you don't, no, we're recording. So, this guy could look like this. And it might have a CH here. CH and then an O. On the end of a chain, if they're not doing the double bonds, it just might be written CHO. Cho again. Cho keeps showing up, huh? Cho or O. Anyway, there's your carbonyl or aldehyde group using a carbonyl. This is the carbonyl, but it wasn't written with a double bond like you see it here. So you need to get used to all of these different ways of seeing that aldehyde group. Okay? Here we go. Now look at that oxygen. It's very different, folks. Very different. Can anybody tell me the differences between this oxygen and the oxygen that we saw in here. This guy was in the middle of the chain, and this guy's in the middle of a chain. What's the big diff? Okay, he's hooked to 2 carbons also, where this guy is only hooked to 1. You see that? You kind of have the idea. That's good. This guy's hooked to 1 carbon, and this guy, when he's in the middle, is still hooked to 1 carbon. But now we have the oxygen hooked to 2 carbons, and that makes what we call an ether. Okay, so there's the ether group, and let's see, what do they call them in here? Ether and ether. So it's ether or ether for the group as well as for the functional group name. All right, here we go. Another hydroxyl. There you go, right on the end. The OH group. And so that, of course, is an alcohol. And your last one here, we got another hydroxyl group in the middle. And we're going to learn about how to name these guys just a little bit differently in some cases, depending on where that hydroxyl group is located. And the last one here, another one that kind of looks like an aldehyde, but it's not. Don't be snookered by that double O. Okay, that's a carboxylic acid. And you'll see that on page 738. Okay, I don't have that in my tutorial. I just don't want to spend that much time on carboxylic acid, so I'm not doing much with carboxylic acid. Any questions on the naming of these guys? I'd like to know by a show of hands, how many of you were able to name these all correctly? Couple? 3? Okay, 3 of you. That's about the same as last period. What that means is that you're just not quite training your eye well enough yet. Okay, it takes a little while to get used to this, and so I thought it was important to go through this homework assignment one by one and make sure that you can recognize these guys. Now, you're only going to be dealing with the hydroxyl groups today. That's all that's in the classwork. But I wanted you to see what these different kinds of compounds are and what makes them different. And that's what this was all about. This little chart is available to you at a link that is located right here if you download the notebook file, or if you download the PDF file. I think the link will be operating. If all you can do is see this, you might have to visually copy it, or you could go to my website and download my files for the date for this particular homework, and you'd be able to get that. But this is a nice comparison for you to see the difference between alcohols, ketones, and aldehydes. And I'll leave that to you to use as you see fit. I also have a link for this page on the homework page tonight. Okay, there's a link right there for you, as there is for the tutorial. If you can't find your tutorial, the link for that will be in tonight's homework page, and the worksheet that you use to do the problems for today, that link will also be there. Okay, here we go. Let's look at alcohols. Now, I really wanted to cover this. Do you notice how this molecule is numbered? The hydroxyl group is treated like any other substituent. The thing is that he has other special powers, which we will talk about in just a second. But right here, we make this side number 1 because the hydroxyl group is closest to this carbon. It's 1 carbon closer to this end than if we count in from this end. Here we go, 1, 2, 3, 4, we get to the hydroxyl. Here we go, 1, 2, 3, and we hit the hydroxyl. This end becomes number 1. Okay? And we name this a lot in a very similar manner to what we did with the ines and the enes. With the ines and the enes, the double or triple bond was also determining who was carbon number 1. So let's go down now and look at how things change or not change with this dude. Now, I've drawn exactly the same molecule. I just added a methyl group here on what we called carbon number 5 when we did it here. So, what is your expectation? Anybody? Oh, I will just call on someone. I would like to know what your expectation is for whether or not this would change the carbon 1. Abdullah, what do you think? Where's carbon 1 going to be, on the left or the right? Okay, you got suckered. I suckered you in. Okay, normally you would be absolutely right, Abdullah. Okay, you would be absolutely right. But the thing that you don't know is the hydroxide group, or the hydroxyl group, not hydroxide. Hydroxyl group determines who is number 1, more important than the other substituents. So this becomes, when we have a hydroxyl, it becomes the most important factor in determining carbon number 1. So this would be numbered exactly the same. Here, let's just copy this down. And this guy's going to have exactly the same numbering for the same reason. And this guy just doesn't affect it. So let's see if we could get something to summarize this. And that something is right here. Let's make sure that's all together. Good. And let's make that a little bit bigger for you. Okay, would you copy that down, please? That's going to be important. Now, before I ask you to name this guy down here, let's look at this guy right here. And I'd like to ask, let's see, Elsa, you're here. Would you please tell us what you think the name for this should be? And I want you to think of enes and ines now, okay? How would we name this? First of all, name it as a plain old alkane. What? Oh, no, that's not a methyl group. You want to name it 3-hydroxyl, right? Yeah. Okay, you want to name it 3-hydroxyl hexane. Okay, now this is going to become an OL ending. All alcohols. You might want to write this down too. All alcohol. I can't say it. All alcohols and an OL. Okay, so you'll look at 5 of your homework problems are going to give you names of alcohols, and you have to tell what the structure is. But at any rate, we're going to do this very similar to the way we do. Instead of saying the alcohol, the hydroxyl group, how did we name our enes and ines? Based on where the bond is. Okay, good. Now, this is also based on where the bond of the hydroxyl group is. Now, try naming it again. No hydroxyl. Just say 3 hexanol. 3-hexanol. That's all you need. The 3 tells us, because this is an alcohol, the 3 tells us that the hydroxyl group is on number 3. That's all. Now, when we go to name this, this is not going to be anything new. This is exactly what you would expect it to be. Okay? Exactly what you would expect it to be. Sean, would you give it a shot? Let's name this second guy. No. We name our substituent first. See, hydroxyl is a super substituent. So name our mortal substituent. Yeah, he's not Superman. He's just plain old substituent. There you go. Good. 5-methyl. And now the rest of the name is the same. 3-hexanol. Hexanol. There you go. Pretty easy? Yeah, okay, great. So that's the naming of the hydroxyls, or the alcohols that have hydroxyl groups. Okay, there's one other thing that you need to know about alcohols. How do you name primary, secondary, and tertiary? And what do those terms mean anyway? Okay, let's go right here And I want you to look at this very carefully. Copy down the structures that you see under primary, secondary, and tertiary. And as soon as you have those copied down, try to figure out what makes primary primary, what makes secondary secondary, and what makes tertiary tertiary.
Okay, the
Harris,
primary has
yeah?
hydroxyl.
I'm sorry?
The primary has hydroxyl, so it comes first.
Okay, hydroxyl is on carbon number 1, and he's hooked to the very first carbon, right?
Yeah.
Okay, carry on. What is the secondary?
Is the hydrogen hydroxyl. So
What?
the second one is the hydrogen hydroxyl.
Okay, understand, all of these guys have hydrogens. All of these guys have hydrogens. This guy, and this guy have hydrogens. This guy does not, but the hydrogen was simply there. I didn't mean to snooker you. I really didn't. But the hydrogen is there to complete the fourth bond. Okay.
Okay, so on the secondary, the OH is on the third carbon.
No, it could be on second, third, or fourth. In this molecule, and still be a secondary. To be a secondary, he just can't be on the end. There's something else that you need to see. Keep going. What do you think the tertiary is?
It has a carbon and a hydroxyl. As an actual carbon.
Okay, I'll give you a stamp on that. All right, let's try. Someone else want to give it a shot? Okay, go for it. Mary. To the... Okay, it's more than just bonds. It's more than just bonds. See, all of these guys have 4 bonds. I'm just not showing it in the skeleton. All of these guys have 4 bonds. I'm just not showing it in the skeleton. So what's unique about this and this that makes it different from being hooked to this carbon? Think carbons now. Okay, Jahis wants to try now. Go. There's no H for what? 4 hydrogens already where? Oh, on this guy? You're looking at these guys. Stop looking at the hydrogens. Start looking at the carbons. Go for it, Lilith. No, it has nothing to do with how many carbons. No? Okay. Romy? Ah, you got it. You nailed it. Excellent. Okay. Say it again. This carbon right here is connected to only 1 carbon. Okay? And then he's got the hydroxyl group. So concentrate on hydroxyl and carbons, and then you'll have it. Okay? And this guy is hooked to how many carbons? And this guy is hooked to... That's where primary, secondary, and tertiary comes in. It refers to how many carbons that the carbon that has the hydroxyl group is hooked to. Okay? Does that make sense now? Yeah. Okay, great. So there's your primary, secondary, and tertiaries, and we are done. This video will have an index, so you can get to any one of the 3 sections of the video by just fast forwarding. And thank you for watching.